Good morning everyone. This session I am going to discuss fundamental principle of counting, which is an integral part of combinatorics. Combinatorics made of two topics, permutations and combinations. But the topic whole of permutation and combination is entirely dependent on the concept you will get here in fundamental principle of counting. You can say that combinatorics is actually the extension of fundamental principle of counting. Whatever we learn in fundamental principle of counting, that is formulated once in permutation and then in combination. This fundamental principle of counting will help you to count number of processes combined. When you consider the number of occurrences of two events one after the other, you need fundamental principle of counting, that is multiplication rule is in use. And when you need to count number of cases, I mean either or cases, then also you need fundamental principle of counting. And this particular topic has so many applications in our daily life also, you won't believe. Right now I am telling you just application in a subject like in modern physics. If you want to calculate the number of ways when an electron jumps from one orbit to another orbit, how many different kind of spectrum you expect from there, that will be understood by using counting principle. Obviously concept is in physics, but fundamental principle of counting will help you to actual number of ways the spectrum you get from hydrogen atom. Okay, without wasting time, let us start the topic. So already I told you about two principles in fundamental principle of counting. The first one is addition principle. Second one is multiplication principle. I am talking about the occurrence of two events. One event E, suppose it can occur in M ways. Another event F can occur in N ways. And suppose that both cannot occur together. Either first event or second event, both cannot occur together. Then E or F, I mean first event or second event, can occur in M plus N ways. For example, I am taking the simplest example to understand this addition principle. Suppose in your school, in a class, there are 20 girls and 16 boys. Your class teacher want to see one of you as the class monitor. You all are equally competent and she is instructed to make only one monitor, not two monitors. So how many ways she can do it? This will be 20 plus 16 ways. So that is equal to 36 ways. Why? Because out of 20 girls, she can select one of them, either first or second or third or 20th. This way 20 possibilities are there. So the event, considering a girl as the monitor of your class, can be done in 20 ways. Similarly, a boy, they are also equally probable. One of the boy can be selected in 16 ways. So one process in 20 ways, another one 16 ways, both together can be done in 36 ways. Clear? Then I go for another example. Suppose from your home to your school. This is your home to your school. There are 3 bus routes. If you go by bus, then we follow one of the bus routes. This is bus 1, bus 2 and bus 3. There are 2 car routes. Sometimes they coincide, but I am assuming that those are distinct. And one way is there, you can reach by walking. Okay. So how many routes are there? In total 1, 2, 3 here. This is another one by walking, and these are car routes. So how many ways you can go from your home to your school? That is by either by bus route or by walking or by car routes. So either or case, it will be 3 plus 1 plus 2. This is equal to 6. Okay. So number of ways you can go from your home to school in 6 different ways. I have added all these possibilities. So this is addition principle, which is very easy to understand. So instead of event, we can consider process. Number of ways a process can be done. Let it be done in m ways, another process in n ways, then either first or second. Both will not occur simultaneously. When you go by walking, you cannot go by bus. So it can be done in m plus n ways. We have extended for 3 cases also. Suppose an event can occur in m ways, another event n ways, and the third one in p ways. Then either first or second or third can be done in m plus n plus p ways. Okay. This is fundamental principle of counting and addition. You can extend for any number of cases. So remember this one as the process for occurrence of an event, or number of ways an event can occur, number of ways and another event can occur. Then their occurrence either first or second can be done by considering sum of 2 cases, sum of 2 processes. Then you go for multiplication rule. Suppose the event E can occur in m different ways, and associated with each way of occurring of E, another event F can occur in n different ways. Then total number of occurrence of 2 events in the given order is m into n. Don't understand? Okay, I state different method. Suppose a process can occur in m different ways, and another process can occur in n ways. Then both the events, joint occurrence of 2 events can be done in how many ways? M into n. Clear? Joint occurrence of 2 events can be done in m into n ways. Let us realize with examples. Suppose in one of the problem here, it is asked in a class, assume in your class 20 boys and 12 girls are there. Teacher want to select one boy and a girl to represent the class for a function. But one boy will be there and only one girl will be there. How many ways can the teacher make this selection? 20 boys are there, 12 girls are there. So either selection of boys No, not either. Selection of boys required, selection of girls also required. So out of 20 boys, they are all equally probable. You can select any one of them. So one boy out of 20 can be selected in 20 ways. You agree with me? Either first or second or third or fourth or the 20th. So it can be done in 20 ways. And one girl out of 12 can be selected in 12 ways. Therefore, total number of selections will be this is equal to 240 ways. Okay. So number of selections of one boy and a girl by using fundamental principle of counting can be done in 240 ways. Can this be continued for 3 different processes? Yes. One process can be done in M ways, another process in N ways, third process in P ways. Then all 3 can be done together in M into N into P ways. We can extend it for any number of cases this method. How many numbers are there between 99 and 100 having 4 in the units place? This fundamental principle of counting in mathematics will help you to solve your problem within a few seconds only, which by actual counting will take a day, but by fundamental principle of counting can be done in, I am telling you, in few seconds. Okay, this problem, if you don't use fundamental principle of counting, then how will you solve, you think? I am doing it with the help of fundamental principle of counting. Between 99 and 1000, between means you cannot take 99, you cannot take 1000. Number cannot be of 2 digits, number cannot be of 4 digits. They are all of 3 digits. Units, tens and 100. 4 will be occupying in units place. Okay? A 3-digit number, 4 is occurring the units place. Whenever you form a number, that you have to do with these digits only 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9 only. With these only, no other option. So don't you think that the number of numbers will be equal to number of ways we can fill up this place and this place, because this place always occupied by 4. You cannot change this. There is no choice for this position. No choice for this position. 4 is, it is fixed here. 4 is fixed. So for this place, how many ways selection can be done for 100th place? Apart from 4, what are the digits? Apart from 4 here, number of digits 9. But 0 you cannot take here. Then don't be a 3-digit number. So this place can be filled in how many ways? Can be filled in 4 there. 0 you cannot take 8 ways. Am I correct? And this place, tens place, no repetition will be there. So 4 you cannot take. You have taken one digit here. So out of 10 digits, how many are left? 2 are in use. 10 minus 2, 8. Okay? So this place also can be filled in 8 ways. Therefore, number of numbers in between 99 and 1000 having 4 at the units place is by fundamental principle of counting 8 into 8, that is 64. Take the challenge. Do it without using fundamental principle. Getting 64 number will not be troublesome for you. You do try for 2-3 hours, maybe 5 hours to prove that it is 64 really. But I am not going to do, because I favor applying fundamental principle of counting to get it. Okay, go for next one. How many numbers are there between 99 and 1000 having at least one of their digits 6? How many numbers are there between 99 and 1000? Let us solve the problem this manner. One of their digits must be 6. Maybe 2 digits of them 6. Maybe all 3 of them 6. And they are also of 3-digit numbers. Between 99 and 1000 means 99 and 1000 not considered, only 3-digit numbers. And considering 6 as 1 digit, 6 being repeated, it is very troublesome to get. I am not going for that. It's a 3-digit number. Then I found it this, I'll try to find it this manner. Required number of digits, required number equal to total number of three-digit numbers minus number of 3-digit numbers, number of 3-digit numbers without any 6. Without 6 as any one of its digits. Clear? You understand this? Total number of 3-digit numbers, units, tens, 100. This place, how many ways? There is no choice for it. Previous sum 4 was fixed, but here it is not fixed. And we will not pay attention for units place. First we will see 100 place. Because 0 cannot be there. If 0 is there, then it will be a 3-digit number. So what we can do there? We first consider the digit for this 100 place. This is not 0. This is any one of the remaining 9 non-zero digits. So this place can be filled in 9 ways. This one, no repetition case we are considering. 0 can be there 9 ways. Then 2 digits are in use in 2 places. Then this place can be filled in 8 ways. So this is going to be 9 into 9 into 8. 648. So total number of 3-digit numbers, we got 648. You will say, no, I know 3-digit numbers more than that. More than that, but with repetition. There you consider 2, 2, 1, 1, 3, 3, 6, 6, 6, all these things. But here no repetition. So without repetition, 648 numbers are there. Now, consider the case when 6 is not any digit at all. So for this part of the problem, we need to keep 6 away from 10 digits. 0, 1, 2, 3, 4, 5, 7, 8, 9. And this place 0 cannot occupy. Okay? So how many ways it can be done? It can be done. Units place can be done in how many ways? No, units place. I'll consider about 100 place first. 100 place 0 cannot be there. Units place 0 can be there. 100 place no. So how many ways? 3, 3, 6 to 8 ways. 0 can come here. How many ways this place can be filled in? 8 ways. How many ways this place can be filled in? This is in 7 ways. You understand? I repeat. This 100 place 0 can't be there. So out of these 8, only 1. How many ways can be there? 8 ways. Then how many are remaining? Remaining number how many? Apart from that 100 place, 0 you haven't taken there. You have taken any one of those 8. That's why 8. Now remaining how many? That 7 plus 1, it will be 8. And for this place, 2 are in use out of 9. So this place is 7. So this is going to be 8 into 8 into 7. Clear? So it is 448 number of ways. Am I clear? So how many total number of numbers there where 6 is at least one digit, at least one of their digit? In this case, I have solved by considering 6 is not taken at all. Then I am going to subtract. But don't you think that there is a possibility of repetition? Okay, I am not considering repetition now. We'll do it later. Just find it. This case. So this is going to be 200. Clear? We did not consider repetition of digits. Repetition of digit if not stated, we don't take. Okay? How many ways can this diagram be colored subject to the following two conditions? These are not two problems. These are two conditions given and your problem is coloring. Each of the smaller triangle is to be painted with one of the color red, blue or green. And no two adjacent regions have the same color. Okay? How many ways coloring can be done? You can use only three colors. Red, blue or green. And adjacent colors cannot be same. Adjacent color means, say consider this one and this one. They cannot have same color. This one cannot have same color. This one cannot have same color. The concept will be confusing for you if you do not apply. If you are not ready to accept the concept of fundamental principle of counting, it will take long time for you and you will do mistake, definitely. So one of the coloring I can show you this manner. Just a minute. Showing you one of the color, red, blue or green. They said, I am taking red. Red I have done here. Okay, coloring with Red I have done. You do complete coloring. Then you go for blue. Blue I am taking here. Okay. Blue I am taking here also. And blue I am taking here also. Green has no use. But somebody says that no, I'll be taking green. I'll be taking green here. Let me take green for this portion. This is a perfect coloring. You see, no two adjacent colors are same. And only 3 colors is in use. But if you start counting this manner, it will take long time. And I have given you a simplest problem here. That number of triangles may be more. How to solve without FPC, fundamental principle of counting? It cannot be solved. We will do it by fundamental principle of counting. And this is your strategy to start with the central one. Central one can be filled in how many ways? This place, instead of red, you can take blue or green. So this place can be filled in, this one can be filled in red or blue or green, 3 ways. Once this one is fixed, it is very easy to decide about this. You can do it without red or green, anything. How many ways this place can be filled in? 2 ways. And this one not adjacent. This triangle, I mean this one and this one, they are not adjacent. Same color you can take there. And this one also. None of these 3 smaller triangles adjacent. Same color you can put there or different. Concept of fundamental principle of counting starts here only. This place in 3 ways. How many ways? This one can be filled in 2 ways. This one 2 ways and this one 2 ways. Total it will be 2 into 3 into 2 into 2. That is 12 ways. Alright. So this one is in 12 ways it can be filled up. No, I am wrong. It is counting mistake. Sorry. It will be 24 ways. Did you all understand? Why 24 ways? You think independently now to solve it yourself. Okay? Let me go for the next problem. 2 bus routes between A and B and 3 between B and C. A man can travel round trip in number of ways from A to C via B. Okay? Two routes between A and B. 3 in between B and C. Does not want to use a bus route more than once. How many ways can you make round trip? Can go number of ways from A to C. And the condition you see, does not want to use a bus route more than once. So this is if they have asked you to get total number of ways you can travel between A and C via B, and going from A to C then coming back to A, then your answer would be 2 into 3 to go, because 2 ways here and 3 ways here, then come back 3 ways. There is no restriction in 2 ways. So total 36 ways you can travel between A and C. Travel between means A to C and then come back. Only from A to C how many ways? 2 into 3, 6 ways. So this is the simplest case, but they have given he doesn't want to use a bus route more than once. Suppose he is going from A to B via this route. This is first burst root, this is second burst root. Okay? And this is third one, fourth one, fifth one. Here there is a restriction. If it goes by burst route B2 from A to B, when return journey is there to come back at A from B, he will not be using this one. He will be using B1. So I hope process you have understood. Now in going from A to B, in how many ways he can go? Initially no choice, he has to go. It can be done in two ways. And B to C, from A to B, and this is from B to C. How many ways? Three ways. This can be done in three ways. Now for return journey, it's going this way, goes this way, now return journey. He cannot come back B from the point C by using the route he or she had chosen. So what they have to do? Suppose they've used B3, then coming back by B4 and B5, only two options left. So coming back from C to B, how many options left? Two options. Coming back from B to A, how many options are left? One option. Let us summarize. Initially going from A to C, how many ways? From A to B, two ways. From B to C, three ways. Coming back as not using the same route can be done in two ways. B to A, not the same route, one way. So total number of ways he can make the round trip is 12 ways. Obviously, it is going to be reduced. It can be done in 12 ways. Clear? Hope you understand. There are 10 lamps in a hall. Each one of them can be switched on independently. Find the number of ways in which the hall can be illuminated. 10 lamps in a hall. Each one of them can be switched on independently. There is no link that you are putting. One switch on means all the lamps are on. No. But it is true that the hall can be illuminated by using one lamp only. Isn't it? If one lamp glows, then the room is illuminated. Light is there. So, how to find how many ways the hall can be illuminated? Again, one more thing you have to keep in your mind, that if two bulbs are on, then also the room is illuminated. 3 on, illuminated. 4 more. 5. It's fantastic. 6, 7. Gradually, intensity of light goes on increasing. Room illuminated. So it was illuminated when one light is on, one bulb is on, 2 or 3 or 3 or all 10. But it is not illuminated when no lamp is switched on. It will remain dark. Quite obvious. So see how I am solving. As all lamps can be on, or 1 or 2, then you can solve it this manner. For the first lamp, it can be on or off. So how many ways? Either switched on or switched off. 1 plus 1, 2 ways. Second lamp, either switched on or switched off. 1 plus 1, 2 ways. Third one, either switched on or off. Fourth one, on or off, either on or off. So state of one bulb, 2. Number of states of a bulb is 2, either on or off. So either on or off means 2 cases. That's why 1 plus 1. For second bulb, 1 plus 1, 1 plus 1, 1 plus 1. For last one also, either it is on or off. Okay. So by fundamental principle of counting, one process can be done in M ways, another process N ways, another process P ways. It continues for 10 bulbs. So how many times it continues? It is 10 times. So you'll see that it is 2 to the power 10. 2 into 2 into 2 into 2. Answer is 2 to the power n. But I don't agree. Why? Because you said that bulb is either on or off. Maybe this one is off, this one off, this one off. These are possibilities, no? We are multiplying all the possibilities. But one possibility contain first bulb is off, not switched on. Second one not switched on. Third one not switched on. Fourth one not switched on. 10th one not switched on. But just one case that you must subtract. Okay? There is one case when none of the bulbs on. That's why subtracted. It is 1024 minus 1, 1023. Understood? Very interesting. You cannot solve it if you don't want to use fundamental principle. Find the number of possible outcomes when a coin is tossed 6 times. A coin is tossed 6 times. How many possible outcomes are there? Coin tossed 6 times. Coin means head or tail. 6 coins. Coin 1, coin 2, coin 3, 4, 5, 6. So when you toss the first one, what are the options? Head or tail. Second one, what are the options? Head or tail. One face will be there. Not like bulb, either on or off. No, either head or tail. So one possibility always there. Either head or tail. Head or tail. This one head or tail. The last one is also head or tail. So how many possibilities here? 2. Here 2. 2. Clear? And you cannot take only one coin to throw and decide. I will not coin on so many. I will not toss so many coins. No, you cannot do it. You are supposed to toss 6 coins over there. So all are compulsorily to be considered. So required number of ways by fundamental principle of multiplication rule, 2 to the power 6, 64 cases. Can you write one case? Yes. First one head, second one head, third one head, fourth one head. This is one case. Can you write another case? Yes. First one tail, then head, 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 head. This way. Can you write another case? Yes, I am taking 3 tails and 3 heads. You really, if you want to do it, do it. It is good. First time you do. First time you need to prove I am wrong or your method is faster. I will happily accept. It will be 64 only. Neither more than that nor less than this. In this context, I want to discuss a very old problem. Number of subsets of a set containing n elements. Elementary idea of set you have. Elements are written by using commas within braces. These two braces are there. N elements you have written by using commas within two braces. How many subsets? What are the subsets? This is the given set. Subset is a null set, maybe a subset. This set is a subset, only A1, A2 there. Even only say A4 is there, this is also a subset. Isn't it? But set contain 1 or 2 or 3 or 4 or 5 or 6 elements. It will take again long time. And value of n we don't know. So definite answer I cannot see by counting. I cannot see. You try. I'll use fundamental principle of counting. Number of subsets of a set containing n elements. Again, the choice. Either one particular element is there or not there. Isn't it? So this particular element either included or not, two ways. This one 1 plus 1, 2 ways. Its next one, A3, 1 plus 1. Either taken order or not taken. The subsets are of this form. There is no compulsion that I have to take all or 2 only or 3 only. For an element there is a choice. You either take or you don't take. And the last one, how many ways? Again can be taken 1 plus 1. So this is being repeated for all n elements. So this product 1 plus 1 into 1 plus 1. This is going to be repeated n times. So answer is 2 to the power n. Am I clear? The answer is 2 to the power n. Number of subsets of this set containing n elements is 2 to the power n. Clear? An excellent problem in this category. Find the number of factors of 72,000. How many factors are there of 72,000? You write prime factors of 72. It is 9 into 8, then 2 into 5, 2 into 5 and 2 into 5. So this is considering 3 square, 2 cube, 2 into 5, 2 into 5. So this will be what? 1, 2, 3, 2 to the power 6. 3 how many times? 2 times. 5 cube. Clear? So 72,000 has prime factors 2, 3 and 5. And how many times they are considered? They are occurring over there. How many times do they occur? They occur. For 2 it is occurring 6 times. For 3 it is occurring 2 times. For 5, 3 times. Number of factor. I just give you example. Here for 72,000, 2 into 3 is a factor. Only 2 is a factor. 3 into 5 square also a factor. You understand what I say? And then 2 square into 3 into 5 cube is also a factor. Writing combinations this manner is not matter of joke. It will take long time. And of course you will do mistake. Better you go by fundamental principle of counting. That 72,000 is made of these prime factors. In a factor, not prime factor, I can take one element or I can take. So how many choices are there for 2? For 2, it can occur once or twice or thrice or 4 or 5 or 6 or none of the times. So 2 can occur in a factor of 72,000 in 6 plus 1 ways. I explain why 6 plus 1, because that factor may contain 2 ones only. Here you see, it can contain twice, it cannot contain also. So how many combinations possible? For 2 it is once or twice or thrice or 4 or 5 or 6 or none can be done in 6 plus 1 ways. How many ways this can be done? 3, either 1 or 2 or none. So 3 can occur 2 plus 1 ways. How many ways this can be done? 5 once or twice or thrice can be done in 3 plus 1 ways. So this will be 7 into 3 into 4. 84 ways. But again there is a possibility like blowing up lamp. Maybe you have not taken a 1, maybe you have not taken a 2, maybe you have not taken a 3, maybe you have not taken a 5. You have not considered any prime factors. That is not possible. So I have to subtract 1. Minus 1, because there is a case where none of the factor taken into consideration. So minus 1. But it will be plus 1. Why? Because 1 is a factor that you have not considered. So answer remains 84. Hope you have understood. Fantastic problem. We are doing all using fundamental principle of counting. Okay? In a certain city, like hypothetical one, all telephone numbers have 6 digits. First 2 digits always being 41 or 42 or 46 or 62 or 64. How many telephone numbers have all 6 digits distinct? So what those starting digits they have given, there is no repetition. It is starting with 41, 42, like starting with 7, it is possible, starting with 9, always possible, starting with 9, 8, many numbers like that. 9, 4, BSNL numbers, 9433. In this city, this hypothetical place, like this, it is 62, 64. How many places are there? 6 digits. We are concerned about these 4. These 5 cases they have given. How many digits? How many digits? 10, 0, 1, 2, 3, 4, 5, 6, up to 9. Telephone number can start with 0. 0 can come in between. It is starting here with 41 or 42 or 46 or 62 or 64. Then 0 can come anywhere. And all digits are distinct. If you have taken 2 digits here, those 2 you cannot take for remaining 4 places. So how many ways this place can be filled in? 0 can be there. So out of 10 digits, how many are left? 8. So this place can be filled in 8 ways. This one 7. this one 6, this one 5. So required number of ways clear? Hope you have understood. So this is 30, 210 and then 8. So this is going to be 0, 1680. 1680 types of telephone number will exist. All 6 digits different, distinct. This is for the sake of problem. In a certain city, only 1680 people are not there nowadays. Okay? It's their problem, but they have asked us to solve, we have solved it. 1680 number of telephone numbers possible. Let us go for next one. Given 4 flags of different colors, how many different signals can be generated if a signal requires the use of 2 flags, one below the other? Colors may be red, blue, green and yellow. Maybe other colors also there. You are preparing signals. No, 4 flags of how many different, yes, how many different signals can be generated if a signal requires the use of 2 flags. So suppose I am taking 2 flags this manner. This is, one is yellow, one flag yellow, and say other one is blue. Blue. One below the other. This is one combination. Okay. So out of 4, for the first place, I can select how many ways? This one can be selected in 4 ways. You agree? Without a 4, 1 can be taken for that place 4 ways. This one, three ways. So together can be done in how many ways? Together can be done in 12 ways. Clear? So total number of signals can be made is equal to 12. Alright? This sum I think going to be challenging for you. Find the sum of all 4-digit numbers formed with the digits 2, 3, 5 and 6. How many numbers? How many numbers? 4 digits they have given. I can get how many numbers then? No, 0 is there. So we can start from anywhere. This can be filled in 4 ways. No repetition there. They have not mentioned. This one 3 ways, 2 ways, 1 way. So total number of numbers formed will be how many? By fundamental principle of counting, 24. Are you going to add all these 24 numbers? Is it possible in this world? Can we add these 24 numbers? Then why you are doing maths? You have studied so many years. Now you are not here to add 24 numbers manually to get sum of all 24 numbers. What you have to do there? You have to use some technique where you can find some of the numbers at units place, at thousand place, sorry, at tens place, 100 place, 1000 place. How to get this? Suppose in the formation of number, I start with the number 3. With 3, how many numbers can be formed? Two five six 265, 625 652, and 562 526. All are starting with 3. 3, 3 and 3. So starting with 3, how many numbers are there? 6 numbers. Starting with 4, how many numbers are there? Starting with 2, how many numbers will be there? 6 numbers. Starting with 3, you got 6 numbers. Starting with 2, you got 6 numbers. Starting with 5, 6 numbers only. And starting with 6. So this way 24 numbers come in. These 24 numbers, sum when you are going to find, then at the 1000 place, we have seen 3 occurring how many times? 6 times. 2 occurring how many times? 6 times. 5, 6 times. 6 is also 6 times. Am I clear? So every digit occurring in 1000 place, every digit in thousands place occur 6 times. Clear? But just little bit sense is required from your side that if 3 occurring 6 times, 2 occurring 6 times, 5 6 times, 6 times here, at 1000 place, what happened at 100 place? 100 place also each digit occurring 6 times. What about tens place? 6 times. Each digit occurring 6 times. Each digit. They jumbled up here. Pattern we got here because we started with 3 or 2 or 5 or 6. But although they are jumbled up, they are coming same number of times over there. So every digit occurring every place 6 times. That is sure. Now, what is the sum of the digits at 1000 place? Sum of the digits at 1 place is what? 6 into 2 plus 3 plus 5 plus 6. Am I correct? 96. 6 into 16, 96. So sum of the digits at 1 place is going to be, sum of the digits here how many? Sum of the digits here 96. Sum of the digits at 100 place 96. Sum of the digits at tens place 96. Sum of the digits at units place 96. Till this concept is okay. What is the sum? Sum can be understood if you understand 7982. 7 is where? 1000 place. Then 9 next place. In the scale of 10, you can add this way. 7982 actually is 7 10 cube, 9, 10 square, 8, 10 and 2, 10 to the power 0. Here also then sum will be what? Required sum is 96 into 10 cube plus 96 into 10 square plus 96 into 10 plus 96 into 10 to the power 0, that is 1. So it is 96 into 10 cube, 100. This product you find, that is the required sum. Clear? Hope you have understood. Problem may be changed, but concept has no change. Okay? I've used the concept of class 5 mathematics. Believe me, not 100% truth, because I've used fundamental principle of counting also. I will be using, because if it is a 5 or 6 digit number, then this way explanation also possible. Next time what I'll do, I'll just find some of the digits at units place, tens place, just by occurring how many numbers are there. From there we find and find the sum very fast. Okay? Two boxes are there and n objects. Find the total number of ways in which n distinct objects can be put into two different boxes so that no box remains empty. Two boxes are there. Box 1, box 2. N distinct object can be put into two boxes. But there is no choice for a particular object. Boxes will not remain empty, that will keep in our mind. At the same time, which object will go in which box, that we don't know. Can go anywhere. So if we go by that lighting of bulbs, that manner, for a particular object, it has two choices, either first box or second box. Second object, either first box or second box. Third one, either first or second. Fourth one, fifth one, sixth one, nth one, either first or second. So how many choices? Two. N times. What's the answer? 2 to the power n. Answer is 2 to the power n. But see the condition, no box remains empty. How many ways then no box will remain empty? Box can remain empty two ways. Either for an empty box, it may be first one or second one. So empty boxes we can get two ways. So -2 we have to do. Okay. This is not end of the sum from this topic. So many problems are there. In this short time interval I have discussed few of them. Many problems are there, and I hope you will start solving problems on fundamental principle of counting now. Okay? Just if I ask you a question, 4 letters are there and 4 addressed. No, that will be difficult. 4 letters are there and in a post office 3 boxes are there. How many ways you can post the letters into the boxes? These are boxes. Okay, big boxes are there. 3 boxes are there. How many ways letters can be posted into the boxes? Similar question? No, it is not similar. Because this particular letter can go to any one of the 3 boxes. For this letter, it has 3 choices. Box 1 or box 2 or box 3. This box contains many letters. Hundreds of letters can be there. You have brought only 4 letters. For second letter, how many choices? 3 choices. This one 3, this one 3. So how many ways letters can be posted into the boxes? These are letters going into the boxes. How many ways? 3, 3, 3, 3, 3. This way. 3 to the power 4. One simple application. This everyone need to know in this society, this kind of things. Okay? Just let me complete this session by asking a question. You got a job in a mint. Mint, you know, where money, what we use every day, that is being made. In a mint, higher authority has ordered you're the employee over there, to keep calendars ready for future years. How many different calendars will you make? In the first day of your job, this offer came. This order came. You make how many calendars will solve the purpose of future years. You know fundamental principle of counting. You have done fundamental principle of counting 9 to 12 level, but you forgot. This is daily life application. That's why I told everyone need to know it. So what you'll do? You'll study fundamental principle again. You'll find that the day of a week can start with any one of 7 days. The year can start with any one of the 7 days. You agree or not? Starting day of the year may be Sunday, Monday, Tuesday, Wednesday. There is no choice. And that particular year may be leap year or non-leap year. Otherwise, only 7 calendars will solve the purpose. 7 different types. So, you need to know whether it is leap year or non-leap year. Depending on that, you will proceed. If it is leap year, then one choice. If it is non-leap year, there is another choice. So, first process being done in 7 ways. Second process in 2 ways. So, both together can be done in how many ways? 7 into 2. That is 14 ways. So 14 different kinds of calendars you have to keep ready. But just by writing the name of the year, you can get a new calendar. Sure? You understand? See you again on this topic. This is combinatorics, introductory topics, where I have explained fundamental principle. And then we'll go for permutation, deriving formula. So many things are there. Thank you for staying with me. See you again.